will begin our discussion on the chemical basis of life. This is 3 parts, and each part will have its own video. So for part 1, we're going to talk about the nature of matter. What is matter? So when we look at the hierarchy of life, we're starting here with these atoms or elements, right? And then we form atoms into molecules, a bunch of molecules into those macromolecules that we'll talk about, and then those make the cell organelles that we'll talk about, which make the cells that we will talk about. And this is all within this module. And then in a couple modules later, we're going to talk about how you put those cells together to form tissues, tissues to form organs, organs to organ systems to an organism. Okay, and then in our 4th module, we'll talk about how those organisms can live together with the same organisms or with other organisms to form the different components of ecology. Okay, so what then is matter, right? You should be able to define matter by now. And what is interesting to note is that it is both something that has mass and takes up space, okay? So to say matter is something that has mass is partly correct. To say it takes up space is partly correct. It is something that takes up space and has mass. So if I said, hey, name some things, you would name a lot of the things that we know as gases, liquids, and solids, right? The table that is in front of you right now, the chair that you're sitting on, your cell phone, okay? The water that you drink, the air that you breathe, the animals, if you have a pet, those are all matter, okay? The paper that you're going to write on. So then what is not matter, okay? So things that aren't matter are going to be those things that are intangible, okay? Something that you can't really pick up and hold in your hand. So time, right? The concept of time doesn't have mass. Gravity, when we think of it, it's a force, but it's not matter. Heat, okay, when we give off heat, memories that you hold, your thoughts, rainbows, these things are not matter, right? So things that tend to be non-tangible, things that are concepts. What are elements, okay? So these are pure substances. They only contain one kind of atom. And when you think of elements, you should think about that periodic table of elements. We have 98 that naturally occur, but there's about 100 and some total. Where do we get the other ones, right? So 98 are natural. The rest of them are man-made. We've talked about these 4 elements that make up most of the human body. And by now, you should be able to name those. Carbon, oxygen, nitrogen, and hydrogen, right? And then the other 2 that makes up about 3% more, phosphorus and sulfur. Remember that. And you can go with CHOPNS, CHOPS, okay? And so an element is the pure substance. It can't be broken down into anything else. It is what it is, right? It is made up of all of one type of atom. Here's our periodic table. So lithium, right? Lithium is a pure element. It's made up of nothing but atoms that make lithium. An atom is the smallest functional unit of matter, all right? So matter is made up of atoms. Elements are made up of atoms. Matter then is made up of elements. Can't be broken down. Each type of atom is an element. Our atoms have a structure to them, right? So this should look familiar to you. So you have these subatomic particles, which make up our atoms. So think of those. These are going to be like monomers of atoms. So you have in your nucleus your protons with a positive charge and your neutrons with a neutral charge. In orbits around your nucleus are your electrons, okay, with their negative charge. The number of protons equals the number of electrons in an atom, giving it no net charge. Those electrons have a particular arrangement to them, and it's called shells in our case. So in that first shell, it can only hold 2 electrons, okay? Every other shell after that can hold up to 8, right? So 2 in the first shell, 8 in each middle shell. The last shell, the valence shell, wants to hold 8 because 8 makes it full. But depending on the atom that we're talking about, it might not have 8 in it. So now this will lead us into the next discussion on bonds. It wants to do what it can do to fill up that shell. Okay? So those bonds. So molecules and compounds, right? Molecules are two or more elements that we put together. That's it. They can be the same, they can be different. They are a molecule. A compound are two or more elements put together, but at least two of them are different, right? So then if a molecule is two or more elements and it doesn't matter the composition, then we know that all compounds are molecules, two or more elements put together. But how we differentiate one from another is saying that a compound has to be at least two different ones, right? So H2O, it has hydrogen, it has oxygen, it's a compound, right? We might say a molecule of water, but we also know it's a compound. And now we can put those molecules and compounds together with ionic or covalent bonds, and that should sound familiar to us, right? So those ionic bonds are the ones that we form by losing or gaining an electron. And when we do that, it gives the atoms that we said had no net charge a charge now, okay? So here we have sodium and chloride. In our sodium, in its outer shell, how many electrons do you see? How many red dots? 1, yes? In the chlorine shell, how many do you see? How many blue dots? 1, 2, 3, 4, 5, 6, 7. We said that 8 is needed to be full, right? So we have 1 here, 7 here. What is the easiest way to make both of these have a full shell? If this guy lost one. So if it loses an electron and it comes over here now, it means it has more protons than electrons and it becomes positive. By this one gaining one, now it has more electrons than protons and it becomes negative, okay? So now we have an Na plus and a Cl minus, and they form an ionic bond. And then that bond holds together because they are attracted to each other. Plus attracts minus. And so if you lose an electron, you become positive or a cation. If you gain an electron, you become negative or an anion. And then with those covalent bonds, we usually share. So here we have a hydrogen. This is its first shell, which needs 2 to be complete. They each have 1. They're going to share. I'll share mine with you. You share yours with me. Now we're full, right? Now we both have 2 in our outer shell. And so they tend to be like they have merged together. And so ionic, lost or gained, covalent, sharing. And then also recall the difference between a compound and a molecule. And then the different subatomic particles that make up an atom.